Alright, student, today we will start with the lecture 2 of definite integration. We did the part 1 yesterday and we covered the major important properties yesterday. Today we are going to cover the periodic properties, properties involving your inequalities, question based on Leibniz and definite as a limit of sum. So these are the topics that we are going to do today. Alright, let's start with some unique topics first of all to start this lecture. So this topic is integration with respect to another function, as you people must have did in differentiation with respect to different function. So here if you see the variable of integration is not x, it is -1 to 1 x square d ln x, right? So the variable of integration, this is the variable of integration first of all, variable of integration. So how do you solve these kind of problems? This is the problem. So yes, so some students immediately can think of, sir, let's differentiate. So what is if we do the partial differentiation of this, right? I have explained you the partial differentiation in the differentiation topic, remember? So if I do the partial differentiation, what is the derivative of ln x? That is 1 by x and then dx. So now you can see this big problem becomes your earlier problem, that is x dx. Okay, and if you solve this, this becomes x square by 2 1 to minus 1. So this is nothing but, can you tell me what will be the answer now? This will be nothing, 1 by 2 minus 1 by 2, the answer comes out to be 0. This is the answer that you should be telling and marking in the answer sheets. But interestingly, this answer is wrong. Very interestingly, yeah. Okay, so can you tell me what is the error that we people have done? Which step is the wrong step? So the wrong step in this particular solution is when you have done here to here. So this is actually the wrong step. And now why wrong? Let me just highlight it for you people. So when you say that initially, so let's talk about variable of integration. That is something important. So that is why in the initial lecture I focus too much on the notation of definite integration. So variable of integration in the initial stage, initially let me talk about initially it was ln x and the ranges that are given. So remember, the limits are actually the ranges of the variable of integration. So this was ranging from -1 to 1, right? This was ranging from -1 to 1. Now you have changed the variable to x, and the error that you people have done is that you have taken the same limits, which is wrong. So it says that ln x ranges from -1 to 1, right? So then what will be the range of x? Absolutely. So x will range from e raised to power -1 to e. So if you wanted to solve this question correctly, the correct answer would have been, you would have to change the limits also. So here you will write e raised to power -1 e, and you can solve as you have done earlier. This step. Now this step becomes correct. Now there is no problem if you put something like this and then you substitute e and e raised to power -1. This is absolutely correct. So the correct answer to this problem is e square minus e raised to power -2 divided by 2. This is the answer that will match and fetch you 4 marks. Okay, interesting problem though, right? This is the general error that we people do. So I am just taking another example to make sure that you people understand the concept once again. So it is 1 by 2 tan x d of sin x, right? Now you can easily differentiate sin x, that is cos x dx, but remember now the variable of integration will not be again 1 by 2 and 1, absolutely. So what you will do, you will take that sin x is equal to 1 by 2. This happens that x equal to pi by 6 and sin x equal to 1. This happens that x equal to pi by 2. So your new limits in this question is pi by 6 to pi by 2. Now whatever the solution will come out, it will be absolutely correct. Don't worry about it. So if I say I, this will be pi by 6 to pi by 2. This will become what? Sin x dx, right? And now you can simply solve it. It is nothing but minus cos x and pi by 2 to pi by 6. And you can then find the answer. I am leaving that part for you people. Okay, so this is how you people have to solve when there is integration, but with respect to the variable of integration is not x, it is some other function. Remember to change the limits accordingly. Now let's take another very interesting topic, that is integration of derivative. So we know that integration and derivative are reverse processes of each other. So if you take this is nothing but inverse of each other, you can say, right? You differentiate this quantity, you integrate, you reach here, you differentiate this quantity, you will reach here. So they are reverse processes each other. So if I say that you were differentiating some function first of all, right, and you were also integrating that function, right, so it actually boils down to saying you should get fx again, right? You are first of all differentiating and then you are integrating. It means you are doing nothing, right? This is what you people should understand. So if you see here, you are first of all differentiating this function. So here fx is 1 upon e raised to power 1 by x, right? You are differentiating and then integrating it again. So your answer should something. So if I have to explain it to you, you should have actually done this only. That's it. Because you are doing nothing, you are just putting the limit. So you do not need to integrate because inside there is derivative. So derivative and integration will cancel out. You can understand it in this way. Okay, and now this question is fairly very easy. Now you can do just 1 plus e minus 1 plus e raised to power minus 1, right? So if you solve this, this comes out to be 1 upon 1 plus e minus e upon 1 plus e. So the correct answer then will become 1 by e upon 1 plus e, right? So I hope you have understood what I meant by the integral of the integration. But again, as usual, this answer is wrong. Now, I'll tell you why this particular problem, this simple concept is wrong. The concept is completely fine. This concept is completely true. That is not a problem in the concept. This is completely fine. The problem that now we have taken is from when we start putting values here. So now let's talk about the function, right? The function is 1 upon e raised to power 1 by x. It is, you can see at x equal to 0, it is discontinuous because x equal to 0 is not in its domain. Because why it is not there? Because you have 1 by x. So you cannot just put the values from minus 1 to 1 because in between minus 1 to 1 here at x equal to 0 there is a problem. So you need to do this question as piecewise function. Make it piece function. That is the problem. So how you will do this problem is you will write something like 1 plus e raised to power 1 by x. You will start from going from minus 1 to 0, but rather than saying 0 you will say 0 minus because you cannot actually put 0. Just closer to 0. Then the next value would be 1 plus e raised to power 1 by x. Then you will go from 0 plus to 1. So this is the correct method of solving this particular problem. Now let me just show you how you solve this particular let's say 0 minus. So this bracket will become what? Limiting case of 0 minus 1 plus e raised to power 1 by x. This will be what? You will put minus 1. You can just directly put minus 1. It will be e raised to power minus 1 plus this will be what? 1 upon 1 plus e, and again minus limit x approaching 0 positive for 1 plus e raised to power 1 by x. So this comes out to be a limiting problem because we cannot directly put 0, so we have to solve using limits. So this is for the first bracket and this is for the second one, right? So how you will solve this now? Yes, so the two components are really very easy, so you can easily solve this and this. So for this I'm taking it here. So this particular limit, let's say here only, so it is x approaches 0 minus. So as x approaches 0 minus, right, sorry, not mine, yeah, 0 minus, so 1 by x will approach minus infinity, and e raised to power minus infinity would be approaching 0. So this quantity actually reduces to 1, right? This quantity is already solvable. What this quantity will become? This will be e upon 1 plus e. This quantity, tell me, yes, this is nothing but 1 upon 1 plus e. And if we solve this limit now, 0 plus, so as x approaches 0 positive, so x approaches 1 by x will approach infinity, and e raised to power infinity will be infinity, right? And 1 upon 1 plus infinity would be 0. So this particular limit, so this becomes minus 0, so that's not a problem. So now if you solve this completely, can you tell me what your answer would become then? Just see quickly. So it becomes 1 plus 1 minus e upon 1 plus e, and if you solve, this becomes 2 upon 1 plus e. This is the answer you people must be looking for. Now just compare, earlier you people were getting this as the answer, whereas answer is 2 by 1 plus c. Alright, a very important concept, looks like a very basic problem, but a huge error is being committed every time we take this problem. So you have to break the limit whenever the function is discontinuous in that particular domain. Now I hope you can quickly solve the other problem, which is minus 1 to 1 derivative of this, and then you are integrating. So if you just write something of tan inverse 1 by x to 1 to minus 1, so this answer you can now understand this will be completely wrong. So one of the answers that you people will definitely get is something of this sort. This is 2 times tan inverse 1, which is nothing but you should get pi by 2. So this answer is completely wrong. Now you can understand that why this is wrong, because x equal to 0 is not in domain. At x equal to 0, the function is discontinuous, right? This is what we can easily see, that it is discontinuous at x equal to 0. So you will have to again do the stuff that we just did earlier, that tan inverse 1 by x from minus 1 to 0 minus plus tan inverse 1 by x from 0 positive to 1. This is something of which you will have to solve, and again for 0 minus you will make it a limit problem, something like this, right? And minus 1, that's not a problem, you just substitute the tan inverse minus 1 here, and the other bracket would be, just quickly solving it, it will be tan inverse 1, and this will again be limit problem, tan inverse x approaching 0 positive. So what will be the value of the first limit? Can you quickly tell me? This, if we see, so this becomes tan inverse minus infinity, right? So what is the value of tan inverse minus infinity? So the shape of tan inverse x is something like this, right? Y equal to tan. I've drawn a very rough diagram, so please don't mind the shape of the diagram. Okay, so you see this will be minus infinity, and if it, as the x is tending towards minus infinity, this value is what is this value? Yes, so this value is from minus pi by 2 to pi by 2, right? So this answer would be what? Minus pi by 2, right? Tan inverse minus 1 and minus 1, so this becomes plus tan inverse 1. This is already plus tan inverse 1, and if we just see minus of tan inverse 1 by, so this will be tan inverse infinity. So this is actually tending towards infinity, and if we talk about infinity, it is tending towards pi by 2. So this will give you again pi by 2. So your answer actually looks like something this, 2 tan inverse 1, right, minus pi. Now can you see the difference? Here it was no minus pi, here you are getting minus pi. So it will be pi by 2 minus pi. Okay, now let us start with periodic properties. So first of all, we are assuming that it's a periodic function. Fx is a periodic function with period t. So very important formulas can be that if you integrate from 0 to n times t, where n here is integer, right? So n can be taken outside, you just need to integrate it from 0 to t. So just keep in mind the diagram of sine x, which will help you. Or in fact, if you want me to draw some simple diagram, let's see this diagram over here. So don't mind the exact geometry, but I am drawing as if it is a completely periodic function. So 1 2 3, so it repeats itself after an interval of 1. So you say 0 to 5, what is the area, right? 0 to 5 fx dx. You can see each of them is a triangle. So can you say that you just multiply by 5 times and just integrate the area of the one triangle, right? This is what is meant by this property. So just understand that n here must belong to integer. You cannot say that n is 32 by 3 and you can solve. Okay, again the next property is that a plus t. You are going from a to a plus t. It is equivalent to saying that you are traversing a one particular period, right? A plus nt, it's just the property using this. So you can say n times 0 to t. See, the middle part of this was actually the first step. I could have written it, it should be 0 to nt, right? 0 to nt fx dx, and 0 to nt again can be written like this. And if it is like something, this is something again a very interesting property, mt to nt, right, fx dx, rather than saying from 0, you can just simply do what, n minus m times 0 to t fx dx, which is again very much visible from this. So for example, you want to integrate this function from 2 to 5, right? 2 to 5 fx dx. So if I started from here, right, and I want to travel still here, so how many triangles are there? 3, right? So that is what is will you get after 5 minus 2. That is what you are getting. This is what I have actually written. Can you see this now? Take a particular example of a periodic function to understand these properties, and just remember these properties. Very important properties. Okay, they are formulas for you again. Let's see how these formulas work into the questions. So let us quickly take examples of periodic functions. So here x minus di of x. So first of all, understand the concept of x. X can be written as its integral part plus its fractional part, right? So fractional part can also be written as x minus its integral part, right? And we know that the fractional part is periodic. Just remember this, right? It is periodic with period. It's periodic with period equal to 1. Okay, you can go to the functions topic and revise this particular stuff. So here the question 1 now becomes actually 0 to 10 fractional part x dx, and since we know it is periodic with the period 1, can you compare that this is now something 0 to nt fx dx, where n is being played by, here n is 10 and t is equal to 1, so you can write it as 10 times 0 to 1, right? And between 0 to 1, how the graph of fractional part behaves, it is actually y equal to x line. So you just replace x dx, and this is the answer that we were looking for. Very simple, right? So 0, and this will fetch you 5 as the answer. If we talk about the second question here, it is actually the same. So it becomes 0 to 100 e raised to power fractional part x. So since fractional part x is periodic, e raised to power fractional part x will also be periodic with the same period as fractional part, that is 1. So again you can say 100 will come down, 0 to 1, and 0 to 1 the fractional part takes value x, that's it. So the answer is 100 into e raised to power x and 1 to 0. So this becomes 100 into e minus 1. This is the answer you must be targeting. Now let's take an under root problem to again understand the periodic properties. So it becomes that 1 minus cos 2x. So we know that what is 1 minus cos 2x. Can you tell me what is 1 minus cos 2x? Yes, so it is 2 sine square x. This is what we people know. So if we do this, right, and we need to take the under root of this. So now again the main concept is whenever you take under root, it is mod x. If you do not do this, your answer could completely go wrong. So for example, if somebody quickly very excitedly writes something of this, right, so then you know for sure that the answer that you are going to give me is wrong. Why? Because now everybody knows that sin x is periodic in nature, right? That's not a problem. So sin x is periodic with period t here is 2 pi. So here you can see that if you play the role of nt, it could be written as 200 into 2 pi. So what you will answer is that, sir, I will take 200 out and I'll do something of 0 to 2 pi sin x dx, right? This is what you people will do. And remember that I have told you to remember this particular stuff also. Okay, so what your answer would come out? Can you tell me? From 0 to 2 pi sin x integral is 0. So this answer will come out to be 0, right? So, but this answer is actually wrong. Now, why this is wrong? We know this because it is modulus x that we should have taken into picture. So this was not the step. The step was root 2 times 0 to 400 pi modulus sin x is the case that we need to take, right? And if we talk about modulus sin x, just go to the functions lecture again. We know that this is periodic with period pi, not 2 pi. So the answer that we are going to do is root 0 to 400. Now, sorry, I'll write it again. So for this, what you will do, 400 will come outside this time around. 400 will come outside and you will say, I'll integrate it from 0 to pi modulus sin x. Sin is already positive in 0 to pi, so there is no need of modulus sin. And I have already in the class 1, the lecture 1, I told you to remember the integral of 0 to pi sin x, which is nothing but 2. So this comes out, this answer becomes Yes, 800 root 2. So this is the answer which everybody is looking for. And whereas if you compare, you were getting answer 0, which is completely wrong. Okay, now let's take another function to understand periodic, and it's a tough problem that we are taking. So I do not think that these kind of problems are going to be asked at mains level, but still we are doing because it could be asked because it is asked at a difficult level at JEE Mains. So this is the gx function that is given to you, and you need to find the values which will satisfy g of x plus pi in these four particular options. So if I say g of x plus pi, it is 0 to x plus pi cos 4 raised to power 4t. So if I talk about a function, let's say cos raised to power 4t, can you tell me what is the period? Yes, very quickly, the period of this function is nothing but pi. I told you in the functions topic that even powers reduces the period by 2 and odd powers remain the same. So if it had been cos cube, the period would have been 2 pi only. So we know that this function is periodic with the period 2 pi. So now let's see how I'll distribute this particular g of x plus pi. So I can break this chart from 0 to x plus pi something like this. See, 0 to pi cos 4t dt, plus now I can move from pi to pi plus x, right? Can I do so? This is cos 4t, right? Now this actually reduces to simple, very simple stuff, g of pi. Why? Because you can just substitute x equal to pi and you will get this. And now this again becomes a formula. So this formula is nothing but, if you compare, it says t to a plus t, let's say cos, or in fact you wanted to write, let's say fx, that's not a problem. You can just simply say 0 to a fx dx. That is what you can say. This is the property. So this actually reduces to your what? 0 to x cos 4 like this, and if you see, this becomes nothing but gx only. So this is, so just search for the answer option which should be matching. So the answer is A to this particular problem. Okay. Okay, now let us talk about properties involving inequalities, and for this you will have to remember two something important formulas. So if fx is less than or equal to gx or greater, whatever you want to, if you integrate it from a to b, the sign remains the same. That means the area will be again greater for gx as compared to fx. The other property here is, if you are integrating a function, this is now for a simple function fx, you are integrating it from a to b, and in x belonging to, let's say, a to b, you say that the maximum value of fx is equal to capital M, and the minimum value of the function comes out to be small m, right? So this is the property that you people can apply, and this is very, very simple to prove. Let me tell you how. So you can say that if fx is there from a to b, this will lie definitely from its minimum to maximum value. Now just integrate. That's it. You will get the property. So even if you are not able to remember the property, no need. Just remember how we have done the proof. This is from a to b, and similarly this will be from a to b m dx, and this comes out to be m times b minus a, small m, and this comes down to be capital M b minus a. This as it is, right? This is what is written here. Let's apply them into the properties in question and see how this property works. So for example, you need to prove this particular step, that this particular integral lies from 4 to 2 root 30 from 1 to 2. So first of all, if I talk about what is the function, so 3 plus x cube, and x belongs from variable of integration is going from 1 to 3. So if you differentiate, what you will get? You will get 3x square, which is in this particular range. If I talk, this is positive, so this implies fx is increasing, right? Or in fact I can say strictly increasing. So in this particular range, you can say that fx will take values from f1 to f3, right? This is what you can say. So what is f1? Just simply and if you can tell me. So f1 would be, if you put x equal to 1, this is 4, right? And what value it will take here? F3. f3 will be 30, right? And now you want under root fx. Now we'll start forming the function that is there with us. Okay, so root fx will be from 2 to root 30. Now you do not want root fx, your target is to solve something of 1 to 3 root fx dx. This is what we want. So obviously what we will do now, we will integrate from 1 to 3 root fx dx will be equivalent to saying 1 to 3 root 30 dx, and here also you will apply the same concept 1 to 3 2 dx. So this is actually your required quantity. Can you see now we have actually got the answer? So this is your required stuff, and this value becomes what? 4, and this value comes out to be 2 times root 30, hence proved. This is how you actually use inequalities, or basically inequality property of definite, in solving the range of a particular integral. So in fact you can say you have found the range of the integral. This is what is meant by this question. So let's take another problem to understand this concept. So it is e raised to power x square. So first of all, this quantity is non-integrable, that you people should remember. So do not get fooled when your friend gives you this particular, in fact this also. So this is something non-integrable quantity. Okay. So now how we'll solve this? Let's see. Again, I'll take fx is equal to e raised to power x square, right? We know that e raised to power x is increasing function, right? And x square is itself increasing in 0 to 1, right? So if I combine both of them, I can say e raised to power x square is increasing in 0 to 1. That's for sure. In fact, if you want, you can just differentiate to check also. For example, if you differentiate, it will be 2x e raised to power x square, and if you check, you will put e raised to power x ex square greater than 0. For x greater than 0, it is increasing. That is what is the answer we are looking for, and we are to integrate for x belonging to 0 to 1. Now again I can say if it is increasing, so that means this value must be lying between f0 to f1, right? What is f0? If you put 0, this comes out to be 1, and then this value comes out to be e. Now again you have got the answer, right? So this property is sometimes very important in finding the range of a particular function where we cannot actually differentiate it, because you must have studied that there are various functions which are actually not integrable. So this answer comes out to be 1, and this answer comes out to be e. So the required quantity is nothing but this will take values ranging from 1 to e. This is what you can say. Now let's take another problem, and we'll use a different property now. So you want to prove that I, which is 0 to 1 sin x by root x, is less than 2 by 3. This is what you want to prove. This is something very interesting question, and it has been asked in AIEEE 2008, I guess. Okay, so how do we solve this? Let's see. So if I again talk about my fx here is sin x by root x. So somehow I need to form sin x by root x using the inequality. So what inequality you people will be using, and why I call this as a peculiar, very interesting problem, is that student failed to remember this. So we know that for positive numbers, for x greater than 0, sin x is smaller than x, and we did this in AOD, right? Now if it is that case, and if you divide them by a positive number on both sides, the inequality will remain unchanged, right? So you can say that sin x by root x will always be less than 1 by root x. Oh sorry, not 1 by, but simply root x. Okay, so I hope now you have got the hint how we are going to solve this. Now nothing needs to be solved, you just need to put the integral sign from 0 to 1 here and 0 to 1 here. So if you integrate it from 0 to 1, what value you will get here? 0 to 1 root x dx. So this will be what? X raised to power 3 by 2, 3 by 2 denominator, 1 by 0. If you check this out, this actually comes out to be this particular value. So hence we can say that I is less than 2 by 3. We proved it. Now for the second part, that is j is equal to 0 to 1 cos x by root x, right? Now you cannot say that cos x is less than x or cos x is greater than x. We have no such particular answer to this, because they are intersecting curves. One is not always greater than the other. So, but one thing is for sure that we know about cos x is that it is always less than 1. Can we say this? It is always true. And now cos x, again the same method. So this will become 1 by root x here, and now you people know what to do. Now again you will integrate it from 0 to 1, 0 to 1. So this is nothing but j. This will become what? X raised to power 1 by 2. This will be what? 1 by 2 and 1 to 0. This gives you answer nothing but 2. So j comes out to be less than 2. A very peculiar question. So you will have to remember how we have actually done this problem, so that you can apply this in a question which is something similar to this. Okay, so now let's see the other rule, which is a Leibnitz rule of differentiation, and this is something very important as per se engineering entrance examinations. And though there are three rules of Leibniz, that is the first and second and third, depending on where the variable x is. So, but the most prominent one is the first rule. Let me just explain to you the first rule over here. So, as we have done in integration, that we know that this is let's say fx dx from a to b. So there, how many options are there for the variable? So variable can be the integrand, right? It could be in the integrand part, and it could also be in the limit part, right? So this is the parts which we need to understand, and that is the differentiation between all these three rules. Now if you see the differentiation of the first rule, so see here that the variable that, or you are differentiating it with respect to x, the variable is only in the limits. It is not in the integrand. Integrand is a function of t. It is not a function of x. So that is why you need to understand this first of all, this logic, that here limits are functions of x, right? So this is the rule when you have to apply when limits are functions of x. So how do you do this? Let me just remove this, what I have written on the right side first. So the rule says that instead of t, first replace the upper value, that is the upper limit, that is f of hx. So make it as a composite function, and then differentiate hx with respect to x, and that's separate, right? This is not in the composite function. Similarly, repeat the process for make the composite function with the lower limit, and then differentiate the lower limit also, right? This is what you people have to do, and then you have to subtract them. So for example, if I have to teach you that differentiate x square, let's say ft dt, I do not know what is the function. So for this I do not need to know what is ft dt, and you are now differentiating with respect to x. So first of all, understand that here limits are functions of x, and integrand here is not a function of x. Alright, so the derivative of this would be that if, now replace t with x square, the upper limit, differentiate the upper limit, that is 2x, minus put the lower limit x, and then differentiate the, yes, so this is the answer if you differentiate this particular quantity. Alright, the second rule says, in fact before going to the second rule, what you people should actually remember is a very special case of this. I should say special case. Why I'm saying special case? Because you might be asked this case at the mains level, not the entire rule. The special case is if you want to differentiate d by dx from 0 to x ft dt, right? So the answer plainly comes out to be fx. Remember this, so add this to your formula list, right? This you should actually remember as a formula. So if you apply this, it will become fx, derivative of x is 1, and you need not do anything with 0, because derivative of 0 will be what? 0, or in fact if there had been a constant, then also the derivative here, this particular component, would be 0. So the only answer is fx. Remember this. Now coming to the second rule, it says now check where the variable is. Now the variable of integration is in the integrand, right? It is not in limits, understand? So it is not in the limits. So what you will do, just take the derivative inside, and if this is a function consisting both of x and t, differentiate with t as constant. T will be taken as constant here. You will not be doing anything with t. So again, if I have to take an example, let's say you are trying to differentiate dx by dt, let's say 1, 2, 3, and it is sine of t plus x, and integral is with respect to dt, right? So what you will do, you will take the derivative inside, that is d by dx sine t plus x, okay, and dt. So now when you are differentiating here, so t will be taken as a constant, so we need not worry about it. So the answer would be just cos x plus t dt. This is what is meant by this, right? T will be taken as a constant, don't worry about it. Okay, and the third rule is actually a combination of all these rules. Here if you see properly that the upper limits and the lower limits are also the functions of x, and the integrand also has a function of x. So the logic says that just add both the rules. Can you see that I've just added both the rules? So I'll first of all differentiate considering that limits are in functions of x, and then I'll differentiate considering that integrand are or integrand is a function of x. So just add both the rules. So as per say your JEE Mains, if I have to talk about JEE Mains only, JEE Mains level. So at JEE Mains level only the first is being asked, and also if I talk about more specifically about JEE Mains, this is the rule which will be explicitly asked in JEE Mains. But if you are targeting JEE Advanced, so you should be familiar with all the three rules. Write them down on the piece of paper to understand how this is working. So for example, for third, you can yourself try differentiating d by dx, let's say x square x cube, right? And then take this sine of 3x plus t dt, how you will differentiate this, right? So for example, what you can do here is that first of all apply the rule to the limit. So limits would be what? Yes, now what you will do, 3x replace t with x cube and derivative of x cube, that is 3x square, minus, then you will, what you will do, you will replace t with x square, then this will be 3x plus x square, right, into derivative of x square, that is 2x, plus integral of 1 x square 2x cube. Now you will take the derivative inside and differentiate with respect to x. So this will be cos 3x plus t into 3 because of the chain rule dt. So this is what will be done for this particular kind of case. Alright, I hope these all three rules are clear to you. So let us see the application of Leibniz rule of differentiation into questions that are going to be asked. And Leibniz rule of differentiation is peculiarly very famous with the limits, very famous, even at both the level, that JEE Main and JEE Advanced. So for example, this is the question. So if you see cot t square, and it is being integrated from 0 to x, right, dt, divided by x, and then you have a limit. So at the first it looks like a limit problem, but immediately you should understand. So now there is a hint. So whenever you see a limits problem, alright, a limits problem plus integral, right, whenever you see something of this, it's inevident that you will be using Leibniz rule. So this is the biggest hint that you can think of it. So whenever you see limit plus integral, just think of Leibniz rule. That is the first step that you should start working on. So for Leibniz, we want to differentiate, right? For differentiation, we know that we have done LH rule, L'Hopital's rule. So people who are not sure of what is LH, just go through the limits video once again. So if you see, this is 0 by 0 form. Why I can say this is 0 by 0 form? Because yes, if you put x equal to 0 here, the denominator is 0. But if you put x equal to 0 here, you are integrating from 0 to 0. That means you are integrating nothing. You are actually, the area is 0. You are standing at a point. So point area would be nothing but 0. So it is 0 by 0 form. That means LH rule is applicable, right? So that means you can now differentiate this. Let's differentiate. So if you differentiate, that's where Leibniz rule comes into the picture, right? So if you differentiate, what will be the answer? Now see, it is 0 to x. We did the formula, just replace t with x, so cos x square, right? Derivative of x will be 1. 0's derivative is 0. So this is nothing but minus 0 divided by what is the derivative of x? This. So you are just left with limit x approaching 0, cos of x square, and this is nothing, this need not be solved. This answer is nothing but purely 1. This is the answer that we wanted to find. I hope the concept of how we have used Leibniz is clear in this particular question. Okay, now let's take a very important problem of Leibniz. It says that I take I as the LHS, that is 0 to sine square x, sine inverse root t. And this is why I say that this is a very interesting and a very important problem, and in fact a very standard problem. Why standard? Because you will find it in each and every book, and I guess every teacher will teach you if Leibniz is being taught to you in the class. Why? Because it has a huge hint and you need to understand what is the hint. So let me just try and build up that hint for you. Here you see sine inverse is being used and cos inverse are being used. We know if we want to simplify sine inverse, we need something of sine inverse sine theta and cos inverse cos theta. This will reduce to theta and this will then reduce to theta. So our target is that inside sine inverse you should have sine theta, and instead of cos inverse, inside of cos inverse you should have cos theta. Is it happening over here? Yes, it is happening. Why? If you replace this sine square with a t, under root will cancel out and you will get sine inverse sine x. And same thing is happening with cos inverse. Yes. So this actually gives you the hint of using Leibniz theorem or differentiating this. Right. And if we try and differentiate this, that is di by dx. So what this quantity will then return to you? Sine inverse of sine x into derivative of sine square x, right? That will be 2 sine x cos x. The formula that I have used here, if you remember, is that 0 to x, right? Or 0 to, let's say, I'll say fx, right? Into gt dt. And if you want to differentiate, so derivative of this is nothing but g of fx into f dash x, right? The first rule of Leibniz theorem. Okay, now if we want to differentiate the other, because 0 is there, so it will be, the component will be 0, plus this will become what? Cos inverse cos x, right? Plus, multiplied by derivative of cos square x, which will be 2 cos x and minus sin x. This is what you people should get. Some people will definitely argue, sir, that since we have done that under root x square is equal to mod x, you should have written here mod sin x and mod cos x. So let's, for that matter, assume that x belongs to 0 to pi by 2 range. For that matter, all right. Now, if we go on and calculate, this becomes x into sine 2x, right? And this will be what? Again, this quantity will become x. This will be minus x sine 2x. Can you see? Because this whole can be again written as sine 2x. So this quantity is nothing but 0. This shows that di by dx is equal to 0. What can you say about I? That implies I is a constant function, because the derivative of a constant is 0. And you are getting derivative equal to 0. That means I is a constant function. That means, now I'll write I again and let me show you what does it mean. So I is constant. That means whatever value of x you put into this, your answer will always be what? Constant. And now you want to prove that this answer is nothing but pi by 4. This is what you are to prove. How can you do this? Can you again tell me? Now we will talk about the second hint now. Can you see another hint that you people have already studied? The other thing that you people have studied is that we know that sine inverse x plus cos inverse x is nothing but pi by 2. We have also done this. And if you see something in this here, you have sine inverse root t, cos inverse root t. What if we add them? We'll get pi by 2. For adding them, we wanted that their upper limits and lower limits should be equal. Their lower limits are equal. We want their upper limits to be equal. When is sine inverse or sine x and cos x equal? So now your target is that sine square x should be equal to cos square x. And we can simply say that this is equal to x equal to pi by 4. If you put, so if I say that at I is nothing but, if I put 0 to pi by 4, this will be 1 by 2. Can I say so? Why I can say that it still be I? Because I know that I is a constant function. By constant function, what do you mean? That whatever value of x you are to put into this, the answer will remain same always, because it's a constant function. So now if you solve this, this becomes 0 to 1 by 2 sine inverse root t plus cos inverse root t. And now we know that this is nothing but your formula for pi by 2, 0 to 1 by 2 dt, and if you solve, this answer comes out to be pi by 4, which is the answer we were trying to match, and hence we can solve this problem. So this is a very beautiful problem to understand the tricks which are involved in a question and how to approach a particular question given what you have already learned. So this is what I call mind map, right? The people who are must be telling you that there is a mind map technique. This is nothing but mind map. Mind map is simple technique where you try and use what you have already learned into the questions given. Okay. Okay, let's take another problem on the Leibniz to understand the concept. It says f is a differentiable function where f is from R to R, f2 is given to be 6, f dash 2 is given to be 1 by 40, and that means it's differentiable at 2. Then you need to find the value at this. So at the first, again, it looks like a limit problem, but as I have already told you, whenever you see limit and the integral, that means Leibniz rule is to be used, and all the information that will be given to you will be to make Leibniz much more productive for the question point of view. So if you are thinking that why f dash 2 is given, do not worry, you will automatically get f dash 2 in the question. So first of all, we need to differentiate this, right? We need to differentiate. But before going on for differentiation, we have to make it LH, right? For differentiation, we will be required to use LH rule, and for LH rule, we know that it should be 0 by 0 or infinity by infinity form, right? This is what is the target. So if you for the time being see this, so first of all, now let me talk straight from the point of view of the question. Here the integral is with respect to t, the variable of integration is here t, and variable of limit is x, so both are separate. So if I talk about this x minus 2 here, can I take this outside? And this could be solved separately, because this is now in the integral. X minus 2 has nothing to do in the integral. In fact, rather I would prefer this to be written something like this. See, f6 to fx 4t cube dt divided by x minus 2. So this becomes my numerator, and I make this my denominator. There is no problem till now, completely acceptable. Why I have done this is because this makes it 0 by 0 form. How? Let's see. If you put x equal to 2 here, this becomes obviously 0. And if you put x equal to 2 here, it will become 6 to f2 4t cube dt. This is what it will tend to. What is f2? Now check. Yes, that is why all the things are given to you in the question. So f2 is nothing but 6. So actually you are doing 6 to 6. When I say 6 to 6, the answer is nothing but 0. So that means here LH rule is applicable. Now you can differentiate without any problem, without any hassles. So if I talk about the denominator, what is the derivative of x minus 2? It will be purely 1. What will be the derivative of this particular component? Let me just highlight, because there are too many things written here. So you want to differentiate this particular quantity with respect to, yes, you want to differentiate with respect to x. So what it will be? 4 into fx whole cube into derivative of fx. Do not forget this part, right? Into derivative of fx. And if we talk about 6, because derivative of 6 will be 0, this will be nothing but 0. And there is now nothing need to be solved in the limits. Can you see? Because you do not have any boundation with the denominator now. Everything is a valid quantity. So this question reduces to finding. Yes. Alright. So now you get the point that why f dash 2 was given to you. Right? Clear? So this is nothing but 4 into 6 cube into 1 by 48. This is what you need to solve for this particular question. And I hope the answer is clear to you. Let's see other question where the Leibniz is completely used. Is specific case where we need to find the range of fx. Now we have found the range earlier in the topic AOD as well, when we did topics of increasing and decreasing. Remember? We did find range of a function using increasing and decreasing. How? If we know that the function is increasing, then let's say from x to belonging to a to b, if it is increasing, let's say it's include both the values. Alright, it includes both the values. So the lowermost value will be fa and the uppermost value will be fb. So this becomes the range of the function. And if it is decreasing from a to b, then the answer would be just reverse of it, that it ranges from fb to fa. This becomes the range, right? So if we can do something similar to here, this particular concept, then our answer would be solved. So now your function is 1 to x t times t square minus 3t plus 2 dt. Okay, and the range of or the domain of x is given to you. Let's start doing the differentiation. If you differentiate this, what this will become? X into x square minus 3x plus 2 into 1, and this will be 0, right? And we wanted to see whether it is where it is increasing and where it is decreasing. So you can just simply see that it is easily broken into factors. So for increasing, decreasing, what you people were doing earlier, that yes, you need to put and check where f dash x is positive. So if I do this step, so yeah, so you just need to draw the wavy curve, right? 0, 1 and 2 are the critical points, plus, and minus, right? And you wanted the region where it is positive. So this is the region you wanted, but your target is to find between 1 to 3. So 1 to 3 will be somewhere, let's say I'll draw a significant line. So 1 to 3 here, right? So can you tell me what is 2, a point of maxima or minima? And these are the signs of f dash x that you people have drawn. So f dash is changing from negative to positive. So what happens when a sign change of f dash changes from negative to positive? Yes, we know that then if negative to positive is the case, this is the point of minima. So for x belonging to 1 to 3, we know that the minimum value will be obtained at x equal to 2. So at x equal to 2, you will get the minimum value, right? So that means if I talk about this particular function, that is fx, so f2 is the minimum value. How you will solve f2 now, that is completely up to you, that f2 is nothing but 1 to 2. Now this is t into t square minus 3t plus 2. And how you need to solve this is the standard approach, that is you will integrate t cube minus 3t square plus 2t. You need to integrate this, right? And if you need integration, I am just giving you a hint, you will have to solve it on your own, right? I am not going to do in depth of it. So this will be plus t square going from 2 to 1, right? This is the value that you will obtain. Now what about the maximum value? Now we still need to find the maximum value here, right? This is still left. So for maximum value, what you will do? Find value at the boundary point. So what are the boundary points? Boundary points are f1 and f3, and we need the maximum value. So maximum function will be used. That means the maximum value of these two will be the answer of the maximum value, and then you will get the range. So for example, f1 is pretty simple to solve, because f1 is that you will put x equal to 1 here. So this comes out to be straight away 0. For f3, obviously you will have to work hard, because f3 will be something solving again 1 to 3, this particular quantity, right? 3t square plus 2t. You need to solve this particular case over here and find the value. So I'm leaving the calculation portion for you guys to do. The maximum value of f1 and f3 give you the maximum value of this function. You have already calculated the minimum value here, so find this answer. Okay, so for example, if this comes out to be a and this comes out to be b, the range you will say then is from b to a. This is the answer that we were looking for. I hope the problem is clear. So now let us take a very important topic, that is definite as a limit of sum, which is important from both the aspect, that is the board as well as your entrance examinations. So what you people have to do is a 3-step process. The first step is that express the series in this particular form. So automatically you will see the limit sign, so we will not bothering about the limit. So whatever the series is, right, you have to convert the series into summation form. That is the first step, summation form, right? And how it has to be in the summation form, that summation of function should be of not fr, it should be r by n, and 1 by n should be out of this, right? I'll explain you with the help of example, do not just worry about this, right? Then if you are able to do so, then the step is very simple, that this particular step here will be reduced to your integral sign, right? 1 by n here, this 1 by n will be replaced by dx, right? This r by n, right, will then become fx. So this is how you convert the series into your definite problem. Now up till now it is only indefinite. Can you see that it is still now in the indefinite phase? You want the limits a and b to be making it definite. So how do you find a? A is nothing but you will find something like this, r lower by n, and b will be nothing but the upper value of r. So what do you mean by upper and lower value of r is that what is the values of the range that r can take. Here you have taken r. So for example, r will start from 1 to, let's say, n. There are n terms in this, 1, 2, 3 up till n. So r1, lower value of r is 1 and the upper value of r is n. Don't worry, I'll just take it in the example to make sure that how it is being applied. Okay, so let's take an example to understand this concept. So this is the question that we have to take. It's a very basic question. So it says that limit this is you need to prove that it is ln 6. So again, if you try and see, this is a piecewise function first of all, right? So generally students do an error that they think that every term here, since it is infinity, so they think something like this: as n approaches infinity, 1 by n plus 1 will approach 0, 1 by n plus 2 will also approach 0, and 0 plus 0 plus 0 will give you answer 0. So they answered 0 in a rapid fashion. But remember, this is a piecewise function. There are infinite numbers or infinite terms, right? So maybe adding infinitely small numbers could give you a substantial answer. So don't ever do this practice. So how we are going to, so first step, so let me start and do with the first step, step 1. So your target is to do with step 1. Step 1 target was to convert the entire thing into summation form, right? So what is the summation form here? So summation form was something that you have to write as 1 by n summation f of r by n, right? Now I'll show you how you can do this. So if this you consider as a series, let me now talk about in terms of series. That is what you people have done in APGP, right? Sequence and series. So if this is the particular series, let's say S is the series here, can you tell me how many terms are there? First of all, so the terms could be easily calculated by seeing the last term. It is 6n. 6n could be written as n plus 5n. Now what is, this is the last term, right? I would say that this is the tth term, last term, and t1 is nothing but n plus 1. So your range is from 1 to 5n. 1 to 5n, how many terms? Yes, you got the answer. That means there are 5n terms. Okay, so there are 5n terms in this particular series. So that means the range of r will go from what? R will go from 1 to up till 5n, right? So if I were to ask you find the rth term of this series, the rth term, what you will say? Sir, it is 1 upon n plus r, and this r will vary from 1 to 5n, all 5n natural numbers. Now you want to write this tr as a function of not r but rather as a function of r by n. So deliberately make r by n. So you can make r by n here by dividing it by n, right? So if I divide by n, so this will be something like this. So every term can be written like this, right? And now it becomes a function of r by n, and also see that you get a, yes. So now the series here can be written as summation 1 upon r by n, and I can take 1 by n outside of the summation because the variable of summation is not n, it is r, where r varies from 1 to 5n, right? This is how you write in the summation format. And remember that there is still limit n approaching infinity outside it, so don't worry about this. So this is already outside. So now your step 1 is clear that you have written this into the summation format, right? I'll just show you the back slide. Remember, this is what we did. This was the target. Okay, now we will just quickly convert everything into what we just did. So summation would be converted to the integral sign. R by n will be written as x. 1 by n will be written as dx. Now your target is to find a and b. So this is the answer we were talking about. So for finding a and b, let me just show it here. I told you the formula. Let's see here again. Limit, this is the formula that I'm talking about, right? N approaching infinity. So it says n approaching infinity, r lower. So what is the value of r lower? Now you can tell me. R lower, r starts from 1. So it is 1 by n. This is nothing but 0. For b, you were to do n approaching infinity, r upper, right? The upper value of r by n. What is the upper value of r? That is 5n. So 5n by n, that is 5. So that means you need to integrate this particular quantity from 0 to 5 upon 1 plus x dx, which is very easy to solve. This is ln 1 plus from 5 to 0, and if you solve this, you will get ln 6 minus ln 1. The answer is nothing but ln 6, which is the answer we were supposed to find. Okay, so this is how definite as a limit of sum actually works. It's a very simple process, very, I would say, very interesting topic where you will definitely get 4 marks. So you should not leave this particular topic. Okay, we'll take more examples to understand this concept. Now let's take the other problem. Here, first of all, understand the drill is to convert this into series and find the rth term. So if you are able to find the rth term, I believe 70% of the question is already solved. So give me the rth term of this particular series now. Right, so what you will say, sir, n is already always there, right? And it is n square plus r square that is getting here. Never try and find the rth term by just looking at the first or the last term. Eventually, you should have to take at least look at 2 or 3 terms to get the pattern, which is very easy and very obvious to find. But the last term is the one which is the most tricky part. If you try and form the pattern from the last term, never try and do that. Now look at the last term. Last term is the rth term, the nth term here is the last one. Okay, t last, let me write it for the time being, is 1 by 2n. So you need something 2n here. So when will this convert to this particular value? For what value of r? Yes, so when r is equal to n, this value will convert to 1 by 2n. So that implies number of terms in the series, is nothing but n, because the value of r is ranging from 1 to n. This is what is meant by this. All right. Now you know the series, so this particular stuff can be written as limit n approaching infinity, summation of n upon n square plus r square, where r varies from 1 to n, right? But what is the thing that you require? You require this to be converted into form of 1 by n f of r by n. Now our target is that we should form r by n. So deliberately what we will do, we have to form r by n. So we will not divide here by r n, because here you can see it is r square. Just divide by n square and let's see what will happen then. So if I do this and I divide by n square on both sides now, okay, so this will become what? 1 by n if I divide by n square, and this will be what? 1 plus r square by n square, right? And what is the variable of summation? So variable of summation is r. So this 1 by n is constant for this. So this actually reduces to something of this 1 by n. Okay, limit will be outside, right? So sorry that for the screen has to be blocked. Yeah, so continuing forward, so this 1 by n can be then taken outside the summation sign, and you can write this as r is equal to 1 by n, 1 upon 1 plus r square by n square. Now this is completely in our step 1 form. So step 1, if I write again, so step 1 used to say that you need to write something in the form of 1 by n f of r by n. This is the summation that you wanted to write. So this is there. Now you just need to replace. So I can say this is nothing but equal to, this value will be replaced, r by n will be replaced by x square, 1 by n will be replaced by dx, and the summation will be converted to this, and a to b. Now our target is to find a. A is again the same process, that limit n approaching 0, r lower to r upper, right? So what is the value of r lower here? R lower ranging from 1 to n, right? So this becomes 1 by n, so this is nothing but 0. And similarly b would be what? Limit n approaching infinity, r upper by n. R upper is what? N by n, which gives you 1. So this complete integral then becomes 0 to 1 dx upon 1 plus x square, which is nothing but tan inverse x from 1 to 0, and the answer easily comes out to be pi by 4. So the answer to this particular limit is pi by 4. Okay, now let's take a bit tricky problem based on definite as a limit of sum. It says you need to find the value of limit n approaching infinity, and this is n factorial raised to power 1 by n by n. So as we have taken the earlier question where series was evident in the question, here you are not given the series in the regular series format where the terms are added in a way. It is a particular product that is given to you. Now our target is to split this. First target is to make series out of it, right? Then only we can, after series, we can go to the summation form. Getting the loop. In the previous questions, you were already given the series and then you were going to the summation. Now there is further a step ahead that you need to first of all form a series out of it. For series, I have a hint here. What is the hint? That n factorial. What is n factorial? Actually n factorial comprises of n terms. Can you see this? It comprises of n terms, and it will go on multiplying till you get a 1 here. So it actually contains how many terms? It contains n terms. I can see this now. So let's do one thing. I'll do this, assume this limit to be a. Since there is power also, I need this power to come outside. Okay, so we have done this kind of question in terms of, if you remember clearly, we have done this in differentiation also, where if the variable was in power, we used to take the log. Don't worry about the limit. Limit has nothing to do in the differentiation process. So you can just take the limit outside of the log also and the derivative also, right? So here it is n approaching infinity, log of n factorial raised to power 1 by n, right? The problem is that you need 1 by n outside, but this will not be done unless until n also comes into the picture. So I can do something of this. Can you just cross check that n raised to power n? Now I can take whole raised to power 1 by n. Is that valid? And now this 1 by n will come outside here. So this I can be written as something like this, right? N factorial by n raised to power n. And if you ask me, I can now see that, sorry, this 1 by n should come inside. All right, so I'm just putting this 1 by n inside. Now the question is solved, and log, yes, I might forget to mention the log stuff. Here also log, right? So log of n factorial is nothing but n into n minus 1 into n minus 2. This goes on till 1. And I can now, n raised to power n means n repeated n times. Each n can be put with n different terms, right? And what is log a into b into c? You can then split them in summations. That is, it will become log n by n plus log n minus 1 by n plus log n minus 2 by n, and this will go on till log 1 by n. Right? Now your series, this looks like a series now to you, right? So the series is actually this which you were asked to find. And if I ask that what is the rth term now, can you tell me the rth term of this particular series over here? Yes, it is nothing but log r by n. So I am starting from this. This is my t1 term. It is not necessary that you should always start the series from this particular end. You can start the series from this end also. If you start the series from this, here it should have been log 2 by n, log 3 by n, and so on. So I can say the rth term is log r by n. So the entire S series now will become what? Limit n approaching infinity 1 by n summation log r by n, range of r. R varies from, the first term is 1 and the nth term is here n. So this varies from r to n. Now can you see that this is the step 1 which we used to do in the earlier questions? Yes. Now quickly do the problem. It says that S is equal to what? This will be log x dx. For a and b, what you will do? Again, the process is r l by n, which is 0, and for b it is r upper by n, which is nothing but 1. So it will be from 0 to 1, right? So you need to find the answer of log x when it is integrating from 0 to 1. I told you earlier also to remember the integral of log x. It is x times log x minus 1 from 1 to 0. So now this is also a very interesting problem to solve, that how you put the limits here. So if I have to try and teach you how to solve this, so let's see, 1 into ln1 minus 0. This is when I put 1 here. And now the problem is that you cannot put 0 here because log 0 is not defined. So then again, remember that we did just in this particular video, that now you will do it in the limiting case from 0 positive x into ln x minus 1. This is what you will solve now. Okay, so the answer to this is pretty obvious, right? So this answer will be nothing but minus 1. I'll have to do a correction here. It is not 0, it is 1, right? Yeah. Okay. So this is minus 1, and how you will solve this particular limit then? So yes, this is the tricky part here. So you will solve this by forming again LH rule. If I try and say that this limit can be written something like this, please see here. So it is ln x minus x upon 1 by 1 pi x. This x will obviously come outside. So this now becomes infinity by infinity form, because we know that when ln is approaching 0, it will return you infinity. Infinity minus 1 is infinity. This is infinity. Now you can differentiate. So if you differentiate, this becomes 1 by x minus of 1 by x square, limit x approaching 0. The answer to this problem is nothing but 0, right? So this is nothing but minus 0. So the value of this entire summation series comes out to be minus 1. But remember, this is not your answer. Now coming back, since we have too much on the paper at this point of time, this answer was what? Yes, answer was log a. So actually what you people have got till now is that log a is equal to minus 1. So the answer then would be what? E raised to power minus 1. This is the answer we are going to mark in the question paper. Alright, watch the video again, because this is a very important question. If a tough question on definite as a sum has to be asked, it would be on the similar lines. Okay. So by this we come to the end of this particular chapter. We have covered the topics which were tricky in this particular lecture. We did the basic in lecture 1, where the properties, major properties were discussed. So a very important chapter as per se your engineering or your board exam, because why I'm saying important, because it is a very scoring topic. If you have done this very in a thorough manner, you'll definitely be able to fetch the 4 marks which is required at the entrance examinations. So do this chapter very thoroughly. I'll again as usual send the worksheets which you can people practice and do for your practice. All right. So again, the for the NCERT part, the videos are available. Just go through them and keep improving. So I'll see you tomorrow with a complete new chapter. And till then, good night.